Yo, we are back again now doing the examples. I'll just say it just in case. Um, go back and listen to the video and explaining the laws of exponents and the definitions we went through. If, of course, you are not confident, because you have to know them by heart. The moment you know them by heart, the easier it will be. The moment you see a problem, you already know which law to apply, right? So we have the first example here. It's just 4 times 4 to the power of 2a times 4 to the power of 2 times 4 to the power of a, right? So what I'm seeing here, there's the first thing, I have the same basis. It doesn't matter what the bases are. And also, just going back on the laws of exponents, I would say it's not really important to know like them in order to say the first one says this, the second one says this, and the third one says this. What's more important is for you to remember that there's a law that says this. It's not important for you to know which law is number this, which law comes first, which law comes last, right? Yes. So you see the law here, you have the same basis. That's number one. And number two, we are multiplying. You already remember when we have the same basis and you multiply, you add the exponent, right? So you already know that whatever your answer is going to be, it's going to be your base, which is 4 to the power of, here it's 1. So you will say 1 plus 2a plus 2 plus a, right? And you can just maybe add it straight away, or you can group it. Let's group it. 2a plus 1 plus 2, and your final answer is 3a plus 3. There you go, you have your answer. Let's do the second problem. Is quite interesting, this one. You have k. Get there. Yeah, and I'll also say just try to pause the video, do the problems, and then play them to see the solution, right? It will be unwise for you to watch the solutions being done without having attempted the problem, right? Cool stuff. So here, now you're thinking to yourself, we have the same basis. Our base is k, right? But at the top, you realize that you are multiplying. So there's k to the power of what? K to the power of 2 multiplied by k to the power of 3x minus 4, right? So in your numerators, you're just multiplying the same basis. So you're going to do what? You're going to add your exponents. Let's start with that. So you can have your k to the power of x, right? So now you have your k to the power of 2 plus 3x minus 4, right? Then now we're just doing the maths. You're gonna have k, say 3x, and 3x, right? 2 minus 4, that's gonna be minus 2. Then you have it, k to the x. Now you start to remember another law. You have the same basis and we are dividing. What does that mean? We're going to subtract our exponents, right? So you have k to the power of 3x minus 2 minus x, and there you have your final answer. Your final answer, 3x minus x, that's going to be 2x minus what? Minus 2. And then you are done, right? Cool. So I just put the third problem there as a nice problem just to test your memory. You have this one. I know, guys, you'll be tempted to try to solve it with the other laws of exponents, dividing 2 with 4 and saying that you have half, and then you have k at the on your numerator, you have k in your denominator. You will try to subtract that because we have the same basis. which of course, I mean, you'll be right, but it's just a waste of time because you have the whole thing to the power of what? To the power of 0. And remember what we said was that anything to the power of 0 is going to be what? It's going to be 1. So here you can just write your answer to say the answer is going to be 1. And then you're done. You don't have to do anything, right? So yeah, I mean, you can solve it step by step, work with the brackets first, and then yeah, but it's just a waste of time. So let's see what we have on the third problem. So the fourth problem, I mean. So here you have we can just work that out. 20 divided by 10, that's just going to be 2, right? Multiply, you see that numerator we don't have the same basis, denominator as well we don't have the same basis, but in the whole fraction we have t as a numerator, t as a denominator, we have p numerator and the p denominator. So we can just apply the law. The law says same basis, you divide, you subtract the exponent. So we have 5 t to the power of 5 minus 4 multiply by p to the power of 10 minus what? Minus 9, which the answer is going to be 2 t to the power of 1, or just t, p to the power of 1, or just p. So that's your answer and you're done. Yeah guys, so like this is just nice examples. I didn't know what to say next. Cool. See you in the next video where we'll be doing rational exponents and sets.